Welcome to qnawire.
So in this problem, you have a truck that's moving at 25 meters per second in easterly direction, and you have another vehicle moving in that same direction at 20 meters per second. And these things are involved in a collision, and you want to find the speed and kinetic energy quantities after the collision. So this is just a straightforward conservation momentum equation. So momentum calculation. So you know that PI has to be equal to PF. So this is your guiding principle for this whole problem. So we know the initial momentum is just m times v plus m times v. So you're going to just write out the equations m1 v1 I plus m2 v2 I should be equal to m1 v1 f plus m2 v2 f. So since you know the masses, this is 1200 and this is 9,000. Since you know both masses here, all you have to do is calculate the total of the left-hand side, which will give you one value, and then you simplify this right-hand side given the numbers that you're given. So you know that after the collision, the second car M1 or the first car M1 is now traveling at 18 meters per second, but the second one is the one that you do not know. So you have all of these quantities except for this V2 here. So it's just a matter of substituting all the values that you have into the equation, and you find, once you complete that, that your V2F is actually 20.93. And it's a good idea to keep this value to keep all the decimal places after this value, because since these numbers are pretty large, the error that you get after you multiply um, with a rounded out value might be larger than you'd expect it to be. So it's a good idea to just keep that stored in your calculator if you're working with it. And this would be meters per second over here. And then the second part asks you to calculate the mechanical energy of this whole system, or the change in mechanical energy after this interaction happens. So the mechanical energy essentially is the kinetic energy of the system. So you want to first calculate Ki, and then you want to calculate Kf and see if there is a difference in this during that happens during this collision. So Ki is just half mv1 I squared plus half mv2 I squared. And Kf again will be the same. It's just half mv1 final squared plus half mv2 final squared. So you notice that you already calculated v2f. So this goes here, but if you rounded it up here, the error will be pretty large because you're squaring and multiplying it by 9,000. So it's a good idea to keep that value as it is in the calculator, the full value. So now, once you calculate these, the change in mechanical energy is just going to be Ki minus Kf, depending on which one is larger. So if you do this calculation, you realize that your change in kinetic energy from the values here is going to be something around 8,680 joules. And this value can go up to about 9,000 depending on how many decimal places you keep here. So it's a good idea. If you want to get this value, just keep 93333 going forward. And that should be it. So you might as well just put a bar on this 9 here. And that's it.